So friends, yesterday we covered till this point, that was doing SSH to our own system. We can have a quick recap of yesterday's class and then we will proceed with today's one. So yesterday we started with installation of Java and SSH. Then we downloaded a Hadoop tar file from my Google Drive location. Then we extracted the
Yes.
content of tar file at some specified path. Then we talked about the important directories of Hadoop. We talked about two type of configuration file. One is default file, which contains default settings. Another are site specific file, which contains user preference or user defined settings. Then we talked about SSH. It's a tool which is used for communication between master and slave services. So even if we are installing Hadoop on single machine, we need that SSH. So we can type SSH space IP of another system. We can do that, or we may try SSH then IP of our own system, or we can even try SSH space localhost. That means connecting from my system to my system. So we covered till this slide yesterday. So you can see that when you are doing
Right.
SSH space localhost, it's asking for password, and that should be there because we don't want that someone is connecting to our system and you can say he's using our data or deleting our data or accessing our data. We don't want that. So it's asking for the password, that's fine. But for Hadoop, and all these things are communicating with each other every few seconds, we cannot enter the password. We can't do that. So to make it passwordless, we have some steps. What we will do is we will be storing the password in a file. But is that a safe practice? Storing my Ubuntu's password in a file, anyone can open that file, anyone can read that, and if someone has my password, my data can be compromised. I don't want that. So SSH is not like that someone can read the password. SSH is quite secure. It stores your password in an encrypted format. That means a human being cannot read that, but a system can read that. Whenever you will do SSH localhost, it will read that encrypted password, it will decrypt it so that it can convert into the original password and it can connect to the system. So this command, I will explain the meaning of each and every word. SSH-keygen. We are generating a key generation. We are generating a key for SSH minus TDSA. T stands for technique. There are many technique available in market for encryption. So DSA technique we will use. Then minus P, capital P, that is password. And after that you can see 2 times single quotes. That means blank. So ultimately we want to make our password blank. After that hyphen F. F means file. Which file would contain my encrypted password? There is a symbol. This symbol is known as tilde. And you can have a look on your keyboard just below the escape key, the left upper corner, and just above the tab key. You can see that is tilde. That is denoting your home directory. Either you can type /home/ your username, otherwise simply use this tilde. So hyphen F, that means file, home directory symbol slash dot SSH slash ID underscore DSA. The ultimate purpose of this command is that using DSA technique, generate encrypted password and store that encrypted password inside that particular directory. That's good. Now one more thing is required. Simply generating an encrypted password is not sufficient. There is a file on every system. The file name is authorized underscore keys. As the name indicates, that whatever keys, whatever encrypted keys are available inside authorized underscore keys, only those are allowed for connecting. Apart from that, whatever else is coming, that is those keys will not be allowed to connect to the system. So you can see now that what I'm doing is cat, then home directory symbol slash dot ssh slash id underscore dsa dot pub, redirecting to home directory dot ssh authorized underscore keys. Ultimately what we are doing is whatever encrypted password we generated in our last step, we are simply appending that to the authorized_keys file. That's all. After that, if you will do, you can have a look at this screenshot. I have done this cat, the complete path of my encrypted file, which contains encrypted password, and appending it to authorized_keys. And after that, I am doing SSH space localhost, and you can see that it's not bothering me for the password now. It's saying welcome to Ubuntu. So this way we can set up the passwordless SSH to localhost. So the next slide we have is modify hadoop-env.sh file. Yesterday we talked about few configuration file, and as I told you that Hadoop installation is completely driven by modification of configuration file. We have to manually modify the files. So I will show you where exactly this Hadoop-env is located and what are the required changes. So just give me a moment. We'll go to my local cluster home. Inside that my Hadoop is installed. Inside that there is a conf directory and hadoop-env.sh. Where is that? Yes, it's there. This one. There are many options. Once I double click on the file, run in terminal, display, cancel, run. I don't want to run it. I want to display it. My purpose is to modify the file. So I will click on display and it will be opening in text editor. There are many things, many lines are already there. You don't have to do anything with that. Only one thing we will do here is we will be adding this line, just this line. Export java_home is equal to /usr. Java is the first thing which Hadoop needs. So you have installed Java, that's fine, but you have to tell Hadoop where exactly the Java is installed, and that's what we are doing here. Export java_home is equal to /usr. You may be thinking from where this /usr came. How do I know where exactly Java is installed? So we have a command for that. I'm coming back to PDF. You can see this screenshot. I am executing command where is space Java. You can notice that there is no space between where and is, but yes, there is a space between is and Java. This is the command. It will give you the location where exactly Java is installed. The very first is /usr/bin/java. Second is /etc/java, and many more. We always go with the first one. Remaining are hard link, soft link, and all other stuff. The first path is /usr/bin/java, but we never give this complete path. We give the path before bin only. The reason being is Hadoop is smart enough that whatever path you will give, inside that it will automatically look for binary. And inside binary, it will be automatically looking for Java. So you don't need to give the complete path. You have to give before bin only. That's why I have given export java_home is equal to /usr. So after modifying of hadoop-env.sh, we are moving to the next file, core_site.xml file. Let me show you where this file is located. So all the files which we need to modify are available inside conf directory only. You can see this core_site.xml. I can open it. If you will double click on XML file, it will be directly opening in a web browser. I don't want that because it will be just displayed. You won't be able to modify. What you can do is right click on this and open with text editor so that we can modify this. So let me just remove something from here. I will remove this. Yes. Why I have removed? Because if you will open core_site.xml on your system, you will find like this. Starting configuration tag and ending configuration tag. That's all. Logically it's blank. Although there is something written, but ultimately Hadoop related settings are not there. Ultimately I can say that this file is blank. Does not contain anything. What you have to do is we have to define the settings inside configuration tag. So let me revert back. Yes. These are the two properties. This is the starting property tag. This is the ending property tag. So ultimately this is one property and this one is the second property. I have defined two properties inside configuration tag in core site.xml. And what exactly that means? Why we are doing that? So let's come back to PDF. We'll explain in more detail. You can see this. The very first property, the name of the property is fs.default.name. When we were conducting the demo class, we talked about the services. There are many services of Hadoop: name node, data node, job tracker, task tracker. This property fs.default.name, it's talking about name node. It is saying that by default where exactly name node service is running, and we are providing the answer to the value in the value hdfs colon / localhost colon 9000. It's telling you that the name node service is running on my local system, my own laptop, and port number 9000. That's all. The port number is not fixed actually. You can use any port which is free, because there are many ports available on your system, but few ports are being used by some services. So you cannot give any port which is already in use. Any free port which is not in use by any other service you can provide here. But as of now, for beginning, let's not go into that mode. You can simply put this 9000 and your Hadoop will start. So this is about first property. Coming to the second one, name of the property is hadoop.tmp.dir. The name itself is meaningful. Hadoop temporary directory. In the demo class, we talked about that every Hadoop job has two phases: mapper and reducer. Mapper is producing intermediate output, and then reducer is actually merging the intermediate output to generate the final output. So ultimately, the intermediate output has to be stored somewhere, and for storing that intermediate output, Hadoop needs a directory. How exactly Hadoop will maintain that temporary data, what exactly it will do with the data, it's up to Hadoop. We are not concerned about that. From our side, we just need to provide a directory. That's all. Remaining things Hadoop will take care at its own level. So I am giving some path: /home /nearest /local cluster home /hdfs. Inside that hdfs underscore temp. Okay, I have given some path. Do we really need to give this path? Absolutely not. You can give any path. You can give your desktop path, your home directory, your downloads, anything. That's first rule. Second rule is, do I need to give this exactly the same name, hdfs underscore temp? No, even that's not mandatory. It's up to you. You can give any name of the directory, abc, xyz, anything, to make it meaningful, because directory name should give you the idea what exactly the purpose is. I have given the name as hdfs underscore temp. You can also give some meaningful name. And the third rule is, do we need to create this directory manually? Absolutely not. That's not required. The first time you will start your Hadoop, it will be automatically created for you. That's quite simple. You can give any path, you can give any directory name, and you don't need to create that. It will be automatically created by your Hadoop. So friends, these are the two properties which we have defined in core site.xml file. Now moving to the next slide. The next is hdfs site.xml file. Just like core site.xml, if you will open hdfs site.xml on your system, you will find blank. That means starting configuration tag and ending configuration tag. That's the only thing you will find. In between starting and ending configuration tag, you will not find anything. That's fine. We will add from our end. The purpose of adding all these things in site specific file is to change the default behavior, because Hadoop has a default behavior for many things. You can have a look for the first property. The first property name is dfs.replication. As we discussed yesterday, that Hadoop maintains duplicate copies of data. And how many duplicate copies it maintains, that is defined in default file. Let me show you. I will show you the same property in default file. So I will go to source directory, src, yes. I will go to hdfs, yes, and hdfs default, this one. I will open it. and let's search for that property, dfs.replication. You can see this. I will highlight so that you can have a look. You can see this. The name of the property dfs.replication. The value is 3 and the description is default block replication. That means by default, if Hadoop, if user is not giving his own preference, in that case, Hadoop will go with the default value, and the default value is 3. That means Hadoop will maintain 3 copies of your data. But as we discussed earlier, that we may not be happy with the default behavior. I want to maintain 5 copy. I want to maintain 10 copy, or I am okay with 1 copy. How to change that? Can I remove 3 from here? Can I make it 1? I can't do that, because this is a default file. You cannot change that. This is read-only file. If you want to change it, copy this property from here and paste into the site-specific file. That means I am copying from HDFS default, so I will paste into HDFS site. That's what we are doing there. I will show you. You can see now. The first property exactly same, dfs.replication. Value is different. Value is 1. So now the same property is defined at 2 places. Default file says maintain 3 copies, and site file is saying that maintain only 1 copy. So Hadoop will go with which? In this case, Hadoop will go with the user's preference. Hadoop will maintain 1 copy. In case you are not redefining this, then there is no doubt, only it will go with default. It will maintain 3 copies in that case. So friends, this is all about the first property. Moving to the second one, dfs.name.dir. As the name indicates, it's talking about Namenode directory. Namenode is nothing but your master system of Hadoop cluster. Hadoop is a master slave architecture, and you know that master is actually controlling the slaves. It's distributing the task. It's not actually storing the data. Master is neither storing the data nor processing the data. It's only for controlling the things, managing the things, and coordinating the things between slave system. But even for coordination and management, Namenode needs metadata. Metadata means what's your file name, what's your file size, what's your file permission, who is the owner of your file, how many parts your file has been subplated into. Because in case you have a big file, the file will be subplated into multiple smaller parts and stored distributively on multiple machines. And where exactly those blocks are stored. And one more thing, where exactly duplicate copies of that block are stored. So there are many more information. Apart from data, the data about your data, the details about your data is known as metadata. So master system does not store the data, that's fine, but it stores all the required detail for your files, for your data. So for maintaining all that stuff, Hadoop needs a directory. So again, I would say, how exactly it's maintaining, it's up to Hadoop. As a user, we can simply provide a directory. That's all. You can have a look. The value of second property is /home/nearest/local-cluster-home/hdfs, and inside that hdfs_metadata. Those 3 rules are applicable here as well. You can give any path, you can give any directory name, and you don't need to create that directory. It will be automatically created. Coming to the last one, dfs.data.dir. Data directory. Where exactly your actual data will be stored. You are copying a 1 terabyte of file. Where exactly that would be stored. For that we would need a directory, and I am providing the path. /home/nearest/local-cluster-home/hdfs. Inside that hdfs_data. And those 3 rules again, any path, any name, and you don't need to create it. So ultimately, the first time you will start your Hadoop temporary directory, Hadoop metadata directory, and Hadoop data directory. These 3 directories will be automatically created. So friends, this is all about modifying HDFS site.xml file. So let's move to the next and the last last file for modification, that is mapreduce.xml. As the name indicates, it talks about MapReduce. That is the processing part of Hadoop. So this file would contain the settings for the MapReduce part. You will open this file on your system. You will find the same, that is starting and ending configuration tag. In between that, we have to add this property. The property name is mapred.job.tracker. I think the name is meaningful, right? It's talking about where exactly the job tracker service of MapReduce is running. And the value is localhost :9001. Very simple. The job tracker service is running on my local system, my own laptop, and on port number 9001. That's all. And one more thing you can notice is, for this property, I have given the description also. The host and port on which job tracker runs. But we did not provide any description for previous slides, right? Actually, description is an optional part. The name of the property and the value of the property are the mandatory things. You cannot skip them. You have to provide that. But description is up to you. If you want to provide, actually we should provide that. It's recommended that we should provide a meaningful description, so that if someone is reading your configuration file, simply reading the description, they can understand what's the purpose of this property. And you can give any description in plain English language. There is no particular format. Whatever best explanation you can provide, you can do that. So in the beginning, because we are in the initial stage of training, to keep the things simple, I haven't provided the description in the previous slides. But later on, once you are familiar with all these things, you can provide a meaningful description to these properties. Otherwise, as far as Hadoop installation is concerned, it's not required. Hadoop will run smoothly without even your description. That's not required. It's only for reading purpose. Okay, so this is about mapreduce.xml. So ultimately, we have modified 4 files. I will quickly show you the names. The first one was hadoop-env.sh. As the name indicates, Hadoop environment. We set up the environment. We provided the Java installation path. After that, we talked about core site, the core settings of Hadoop, basic settings. Then we talked about HDFS site, the storage related settings. And finally, MapReduce site, the MapReduce related setting, the processing part of Hadoop. So these 4 slides, modification of configuration file is the most important part of Hadoop installation. Okay, so let's move to the next slide. Format name node. We need to format the name node. You must have created some logical drive on your laptop sometime. Suppose I have a D drive of 100 GB, but I want 2 drive, D and E, and 50 GB each. I can do that. That's not a big deal. On Windows, you can go to administrative task, and from there you can create a new logical drive. But after creating logical drive, you need to format that first time. After that, it's ready for use. But are we adding any logical drive here? No. Although we are not doing any logical drive here, but we are adding a new file system. Till now, there is only one file system, that is your Ubuntu file system, right? But along with your Ubuntu file system, I am adding one more file system now, that is HDFS, Hadoop Distributed File System. And in order to use that HDFS, you need to format it first time. After that, it will be ready for use. So how to do that? You have to execute this command, /hadoop namenode -format. We will execute this command from bin directory of Hadoop. So let me open the terminal and we will do it practically right now. So I have opened the terminal and I can maximize it so that you can have a better look. Okay, the very first thing is, let me check my present working directory. I'm inside /home/nearest. But for executing any Hadoop command, you must be in the bin directory of Hadoop. Yesterday we were talking about the directory structure of Hadoop, and I explained you that that bin directory is containing the commands for starting and stopping Hadoop and all that stuff. So what we will do is, I will use cd command, change directory. I will go local cluster home. Inside that I have Hadoop 1.2.1. Yes. Inside that bin. Yes. My present working directory is this one. /home /nearest local cluster home Hadoop 1.2.1 and bin. That's good. And I will execute the command /Hadoop space Namenode space hyphen format. This is the complete command. I will press enter now. It will do a lot of stuff. It will display a lot of lines over the terminal. We don't need to read each and everything. But one thing we have to make sure that this command really executed successfully or not. Sometimes we executed the command, it displayed a big error and we thought, okay, it's done. At least we have to make sure. So for making it sure, what we can do is, I will show you some success message. You can have a look at that. You can see this. Storage directory /home /nearest local cluster home inside that HDFS underscore metadata has been successfully formatted. This path we have given in our one of the configuration file, right? And I told you this will be automatically created. You will start the Hadoop. So if you can see some type of success message, that means it's good. We have successfully formatted our name node. Otherwise, if it's giving some error, you need to look into that and you have to fix that. Sometimes there are syntax error in XML file, configuration file. You started some tag, property tag, but you forget to end that property tag and you are formatting your name node. In that case, it will throw some error. So make sure that the command you are executing is successfully executed. So with this, we are done with formatting our name node, and now we are ready to start our Hadoop. Let me quickly remind you what we have done till now. The very first thing we did is installation of Ubuntu, because without that you can't install Hadoop. After that, we installed Java and we installed SSH, because those are prerequisite for Hadoop. After that, we downloaded Hadoop tar file from Apache website. We extracted the tar file because tar is a compressed file. We extracted the content of tar file. We modified the configuration file. We made the passwordless SSH. And finally, we formatted the name node. Now we are ready to start our Hadoop. So first of all, I will clear my screen and I will type the command /start-all.sh. The command is quite simple, start all. Start all means start all services. We have name node, data node, job tracker, task tracker, and a backup that was secondary name node. We have these services. So once I will type this start all.sh and I will press enter, it will start all those services one by one. You can see that. Currently it's saying starting name node, then starting data node, starting secondary name node, starting job tracker, and finally starting task tracker. It's saying starting. This does not mean that it has really started. Suppose you did not install Java on your system and still you are doing start all.sh. Even in that case, it will say starting name node, starting data node, because it's saying starting, it's trying to start. It's not saying that it has really started. So how to check? I want to really check whether these 5 services started or not. So we have a command JPS. JPS stands for Java processes, and Hadoop services are nothing but Java services only behind the scene. So we will simply type JPS, press enter. It will display the services which are running. You can see the first one, data node, along with some process ID. This number is nothing but process ID assigned by your system, and this number will be different every time. So you don't need to worry about that number. Just look at the name. So data node service is running. Secondary name node service is running. That's good. JPS is also there. JPS is displaying Java services, and JPS itself is a Java service. That's why when I'm doing JPS, it's also displaying JPS. So for our Hadoop related discussion, you can ignore that JPS. The remaining things are data node is running, secondary name node is running, job tracker is running, task tracker is running, and finally name node is also running. So all the storage services, all the processing services, and one more secondary name node, that's the backup. All 5 services are running perfectly fine. That means when you are doing JPS in your terminal, and if you can see these 5 services running, that simply means that you have successfully installed Hadoop on your system. So I'm coming back to PDF to show you. You can see that I have taken the screenshot as much as possible for your convenience. So you can see this. From the bin directory of Hadoop, you will type start all.sh. It will start all the services. Using JPS command, you can verify that whether all services really started or not. If all 5 services are running, that's good. But suppose something is missing. You started Hadoop by typing start all.sh. Then you did JPS. 4 services are running, but Datanode is not running. Suppose, what you will do in that case? In that scenario, log files are helpful. You will go to the logs directory. Inside the logs directory, you will find the log and separate log. One log file for name node, one log file data node, job tracker, task tracker, secondary node. You will find separate log files. Since your data node service is not running, we will be opening data node log file. Go to the end of the file, try to understand the error, try to understand the exception, whatever is there. If you have got the point, you can fix it. Suppose there is a syntax error in XML file, it will display the error message that line number 7 in core set.xml is not having the closing property tag, something like that. So you will get an idea what the issue is. Accordingly, you can fix that and then try starting your Hadoop again. So when the things are moving in the right direction, logs files are not required, we don't need that. But when the things are not moving in the right direction, when something is wrong, logs files are quite helpful. So friends, this is all about how to start Hadoop. And finally, once we are done with our practical stuff, we need to stop Hadoop. And it's very important thing. Never ever shut down your system without stopping Hadoop. Because sometimes what we do is, we start Hadoop, we did the Hadoop related things practically. After that, we opened internet, Facebook, LinkedIn, Twitter. We closed the browser, we shut down the system. Did you notice? We missed one thing. We did not stop Hadoop. That's very common mistake in the beginning. If you will do that, the next time you will start Hadoop, there are chances that it will not start. The proper way is start Hadoop, do your things practically. Once you are done, stop Hadoop. So how to stop? It's quite simple. From the bin directory of Hadoop, you will type stop all.sh. As the name indicates, it will stop all the services. You can have a look at the screenshot. And to verify, you can again type JPS. It's displaying only JPS. That means Hadoop related services are not running now. That has been successfully stopped. Okay. So friends, with this slide, we are done with Hadoop installation.